Okay, this is Mike with Edge On Up, and we're going to do kind of an interesting tutorial here. As you can see, we're out of the knife business and into the scissor or shear business, as the case may be here. We have been measuring scissors and shears sharpness for a number of years now. And let me go grab another scissors here. Okay, I'm back. And of course we've had to do it by measuring the sharpness of one edge at a time using our TMO2 test media. So first we measure this edge and then we measure this edge, or at least our customers do. So this, I think, is going to be, or at least should be, the sort of the holy grail for scissors and shears, and for that matter wire dikes, nippers, for instance, like those nippers that are used in podiatry and so on and so forth, because now we're gonna measure the force required by a shears or an implement of that sort while it's actually cutting something. In other words, while it's being used as it was designed to be used. And that has just got to be huge. So for those involved in that segment of the business. So the way we're set up here is I've simply put this shears, and this is a brand new kitchen shears. It's not an expensive one. I think that was like, I don't know, 14 bucks for 2 pair. And it was advertised as a kitchen shears. And as you can see, I've stuck it in a vise, or at least the lower handle of it. And I stuck a couple of magnets on this vise just to keep it in place. But it's just an old, ordinary, cheap vise. So you could use any sort of vise that is appropriate for the task yourself. So anyhow, but the way we're set up is I'm hooked up to my laptop here, and I'm running Edge Lab Pro. And the reason being is because I want to graph these tests that we're about to run. And I say tests, we're going to combine tests here because Edge Lab Pro allows us to do that, because I'm running it in manual mode, which means I start and stop the test manually, as opposed to letting the computer make the decision for us when to start and stop. And so I think what we're going to do here is we're going to measure 2 different times of test media here, and we're going to keep it all in the family here, and we're going to snip some this is SLC slice test media, so we're going to make a longer cut with it, and then we will switch gears while the test is still running, and we'll do a couple of tests with using best test media, and we'll just have a look at those and see how those compare and what they tell us. So and then after we run those tests, then I'll take this laptop back to my desk and I'll come back on and we'll analyze the test and see what we ended up with. So, okay, let's open this Shears up. I'll tell you what, well, all right, I'll make up my mind here about how we're going to do things. So let's open this fairly wide, and then we're just going to take this test media. Now, if you remember, this is just a polymer compound, so plastic in other words, and it's an inch wide, and I'm just going to and only 0.010 of an inch thick, or 0.24 millimeters, and I'm going to just sort of stick it in here, hopefully. There we go. And then I'm going to come over here and start the test. And then we're going to snip that plastic into, it's telling me that we're not zeroed out here. Now we are. Now it will let me start the test. Okay. And this is all we're going to do here then is just press down on this. Whoops. Maybe I better hold that a little bit. There we go. Okay, there we go. Now let's move right over then, because our test is still running here. We're still logging data, although we're not logging any zeros right now. We'll open this back up, and when we open it back up, now that will be on the test because we racked up a little force here, and I'll just loop that over here, and I thought I had it looped over. Okay, there we go. If I could see it would help. Okay, there we go. Now we're out here closer to the point. And there we go. All right, so I'm going to stop this test. And I see that we've generated a graph. And let me take this back to my desk and I'll be right back. Okay, we're back with our graph here. And it looks kind of interesting. And I've kept it live here on my laptop screen so that we can see these individual data points, because once we save the graph, we can't see this sort of information. So these numbers up here don't mean much other than perhaps this max force number, which is 896, and that is going to occur up here somewhere. But anyhow, these numbers don't mean much because our average force, total test time, so on and so forth, because we actually combine 3 tests into one. So it's the average of all these numbers up here. So here's our first test with best slice test media. And I find this kind of interesting because it never actually plateaued out. Perhaps maybe here just at the end. Now maybe if we would have done a longer Shears cut, maybe it would have eventually sort of plateaued out. But I think what's going on here, and you scissor sharpeners could have a better opinion than mine is, but it appears that the farther we got away from our fulcrum point on the shears, the more force it required to cut through the same material. And so we just never got to the point where it plateaued out. And that is sort of borne out by, I guess, here's our first best, all this in here is just us sort of muxing around here during the test. So the test actually began here and then peaked out here at somewhere around 326 with our best TMO2 test media. And so this was done much closer to the fulcrum point of the shears than our second test, which begins right here and required a considerable amount more force because it was more towards the tip or point of the shears, whatever the proper terminology is. So there we were, looks like around 540. So 540 versus 373. So anyhow, that's I find that all very interesting. The only way to truly understand this is because this data is correct. The way to truly understand it is to use different materials, different widths of materials, different longer cuts, and then we can actually see how a scissors or shears actually works in terms of the force required to do a certain amount of work. So anyhow, that's good stuff. So anyhow, I think that about wraps it up. So thanks for tuning in. And when the music comes on, that means it's time to turn the lights in our sharpening room off.